Right, welcome to our third lesson on revising for your exam. Today we're going to be looking at questions that are asked around bounds, and we'll be focusing on grade 6 kind of questions, or basically all grade CB kind of questions. I would like to pause the video and try question 5. Right, so hope you've tried that. A number, when rounded to 2 decimal places, equals 0.40. This is the decimal place we're talking about, 40. Now it means that this number was 3 decimal places initially. Now to do this kind of questions, I normally copy the number in a number line in the middle. So that's going to be 0.40. And then what I do now, I think about the next number that would have come after that on the number line, which is going to be 0.41 because they're 2 decimal places. So after 40, you go to 41. Then I think about the one that was on this lower side, which is going to be 0.39. Okay. Now, the numbers that were rounded to 0.40 would have been rounded to 0.41 or even 0.39. But they chose to round them to this one, which means that there were numbers that were closer to 0.4 this side and far away from 0.41 that side, which means this would be the boundary. Or they would have been closer to 0.40 instead of 0.39 that side. So this would be the lower boundary. So what you need to do is to figure out what this number is. If this is 40 and this is 41, if you ignore the decimal place, then this is going to be 40.5. Now that doesn't make sense that much because you got the decimal point, but what I could do is to try look at this as 400. You put 0 there as a placeholder. And you can read this by ignoring the decimal place. So this is 400 and this is 410. The number in the middle will be 405. And all you now need to do is put the decimal point in front. Okay? And then here I've got 390, put the 0 there as placeholder. So the number between 390 and 400 in the middle will be 395. And all you need to do, you put the decimal point back and the 0. So it means that the lowest number possible that you have rounded up to 0.40 is 0.395, and the highest possible would be less than 0.45. Okay, so therefore the answer to this would be 0.395 is the smallest possible number, which is 3 decimal places, that will round up to 0.40. Okay, so that's how to do that. I would like you to pause the video and try question 8. So pause the video and try question 8. Okay, hope you've tried question 8. Question 8 says, Max wants to paint a wall that measures 2.1 meter by 5.2 meter. Now, straight away, this wall is going to be a rectangle. So what I'm going to do now, I'm going to need to find the area of this rectangle. Now, remember the area is length times width, but I'm not going to rush until I read everything. A tin of paint states that it will cover 3.5 square meters. If the tin contains exactly 0.5 liters of paint and all other measurements are correct to 1 decimal place, find the maximum volume of paint needed to paint the wall. Okay. The maximum possible volume of paint that will be needed to paint the wall will be when the wall is as large as possible. Now remember, 2.1 and 5.2 were rounded to 1 decimal place. So what you're going to need to do is to work out what they would have been in terms of 2 decimal places. Again, you will do the number line as I showed you. So you put the 2.1 here. And then think about the next number that will have been after that. That's going to be 2.2. And that's going to be 2.3. Okay, no, 2.0. Right. Now, they chose to round the number to 2.1, not this and not that. So which means that the number wouldn't have been more than that, and the number wouldn't have been less than that. So I want to find the number that is here and the number that is there. Again, you can add 0 there, and you add 0 there. The number between 10 and 20 is 15. And in front, I've got a decimal place with a 2. And the number between 0 and 10 is going to be 0.5. And I've got 2 in front. Okay. So this is the smallest possible length of the window. And this is the largest possible length of the window. I'm going to go for the largest possible because, remember, I want to work out the maximum amount of paint I might need. The maximum amount of paint I might need will be when the length is bigger and the width is bigger. Now, if I do the same, finding the upper bound, the lower bound for the width, I'm going to find that the largest will be 5.15. Okay, you do the very same method. Right. So then all you need to do is to put that in your calculator. So if you do 2.15, so 2.15 times by 5.15, the answer is going to be so 2.15, so 2.15 times by 5.15. So going to be 5.15. That was basically a mistake on that. This is 5.2, so it's going to be 5.25. Okay. So if you do 2.15 times by 5.25, the answer is going to be 11.2875 meters square. Okay, so that's the area that you want to cover. But we've been told that a tin of paint states that it will cover 3.5 if it's rounded to one decimal place. Right? So one tin is going to cover 3.5 meters square. But you see now, I want to work out the maximum number of paint. So I'm going to be thinking about this tin being only able to cover 3.45 being the lower bound. Okay, so I'm pretending that one tin can only cover little as 3.45 because I want to find the maximum number that I want. So I will need more tins. To find out more tins, I will pretend that the tin can only do small bit, which is going to be the lower bound. Okay, but you see now the area I want to cover is this. So to find the number of tins, I'm going to need to divide that number 2875. I'm going to divide it by this here. Okay, so you need to do that in your calculator, and the answer is going to be 3.271 recurring 739 and so on. Okay, so this is going to be the number of what tins that you're going to need. So that's what I want you to understand first. Right, so this is going to be the number of tins I need. Remember, you know to round up anything because they're asking us the volume. They're not asking the number of tins, they're asking us the volume. So you need to be careful. Don't round this one up to 4 tins yet. All we've worked out is the number of tins we need in exact. So it's going to be the area of the larger one divided, the area of the window divided by the area that one tin can do, 3.45, which is this one here, right? So that's basically the number of tins that I need. But one tin contains 0.5, right? So that means that the volume, how much paint I'm going to need, is going to be 3.271 recurring 739 times by 0.5. So in your calculator, you just times the answer you still have on the screen with 0.5. And if you do that, the answer is going to be 1.6358 recurring and so on. Okay. If you round this one up, it's going to be about 1.64 liters. Okay. Remember, it's the volume. All right. So hope you get that. So questions like this, you got to interpret very, very well. You got to interpret these ones very, very well. So going back again, you need the largest possible window because you are trying to find out the maximum amount of paint. So the window will have to have upper bounds for the dimension. So the upper bound for the length, the upper bound for the width. Times them, you get the largest possible area. Okay. Now, they say that one tin can only do 3.5, but we want to maximize the amount of paint, which means we're going to go for the lower bound now. We pretend that the tin can do less of the area. So the lower bound of 3.5 would be 3.45 if you consider that it was rounded to one decimal place. So then we do the area of the window divide by the area that can be done by one tin to tell me how many tins I'm going to need. I need 3.27 tins. Now one tin holds 0.5 liters, and this was not rounded, so 0.5 liters exactly. So you just times the number of tins, which is this, times by 0.5, which is going to be this one here, and all you need to do is to round it up. So the answer would be 1.64 liters to 2 decimal places. Okay, and that is how to do a question like this.